Welcome to the Great Basin Astronomy Festival. We are happy to introduce one of our guest speakers, Dr. Alex Lockwood, from the Space Telescope Science Institute in Baltimore, Maryland. She will be discussing the new James Webb Telescope and all of its new amazing technologies.
And I'm the project scientist for Web Science Communications at the Space Telescope Science Institute. I'm here to tell you about NASA's James Webb Space Telescope, or as we like to call it, our cosmic time machine. You may have heard of the Hubble Space Telescope, which is celebrating its 30th anniversary this year. Adds some incredible discoveries about the beginning of the universe and galaxies and stars. And it's taken some beautiful images, some of which you can see here: the Lockwood galaxy, the Veil Nebula, the Lagoon Nebula. And it's actually Hubble's discoveries and also its limitations that inspired the James Webb Space Telescope. One of Hubble's most famous discoveries was that of very, very distant galaxies. You can see here in this image a galaxy cluster, and highlighted and zoomed in are a few reddish blobs that are actually very, very distant galaxies that are from about 500 million years after the Big Bang. That's right, because of the travel time of light through the universe. The further away something is, the older it is. And so Hubble is able to look so far out into space that it can actually see some of the galaxies that were created only 500 million years after the Big Bang. But there was stuff before that, and the first galaxies were created earlier than what Hubble can see. The very first galaxies, we think, look very similar to the images here in that they're faint and red, but they're actually redder than red. So what is redder than red? Well, it's infrared. This is a diagram of the electromagnetic spectrum, which is basically the name we give to all the different types of light there are. You may have heard of X-rays or microwaves or radio waves. These are all different kinds of light with different wavelengths. Hubble Space Telescope sees invisible wavelengths, which is also what our eyes see. It's a rainbow. It's blue, red, purple, yellow, orange, green. But there are other types of light, and wavelengths that are just longer than red wavelengths that our eyes can see are called infrared. The James Webb Space Telescope was designed to see these infrared wavelengths. The earliest galaxies in the universe emit their light at infrared wavelengths. So it is only with the James Webb Space Telescope that we can actually discover the first galaxies in the universe. Fortunately, there's a lot of other opportunities for us in space with infrared wavelengths. The image on the left shows the Eagle Nebula, both in visible and in infrared wavelengths. And as you can see very different structures in these pillars of gas and dust. And you can actually see through the dust to see stars and planets being formed inside these pillars. If we look at galaxies using infrared wavelengths, we see a whole new side of the galaxy. We see the dust emitting strongly, and we can see where new stars are being formed. We can see how that dust and gas is interacting with the central supermassive black hole. We get all sorts of new insights into galaxies using infrared wavelengths. And we can study really interesting molecules using infrared wavelengths, like methane or water. We can use infrared wavelengths to study extrasolar planets and their atmospheres to see what's out there. And the image on the right is actually from a press release that I did during my research career, where we found water on an extrasolar planet called Tau Boötis b. So in addition to being infrared, James Webb has to be very large to see the earliest galaxies because they're so distant, they're very faint. James Webb is about 7 times the size of Hubble in its mirror size and its collecting area, which makes it a very, very powerful telescope. And it gives it the opportunity to have the same beautiful clarity and take the same beautiful pictures that Hubble does. This is a life-size model of Webb, that was on display at the Goddard Space Flight Center, where a lot of the work has been done for this telescope. You can see people here to scale, and this gives you an idea of how big this telescope really is. In this image, you can also see the giant sun shield that is used. That's the giant silver thing on the bottom of the mirror that's used to protect the mirror from the harsh radiation of the sun when it's out in space. However, this giant telescope still needs to get into space. And so when we were planning James Webb, we had to find the biggest rocket there was, and that was actually the Ariane 5 that's owned by the European Space Agency. And so we partnered with the European Space Agency to use their Ariane 5 to send James Webb into space, but it still wasn't big enough. And in fact, we had to build a folding telescope so that it could fold up to fit inside this huge rocket fairing, so that we could send it out into space, where it, of course, has to unfold. Now, this unfolding is one of the most incredible engineering feats that NASA has ever even attempted. While most telescopes, when you send them out into space, they maybe have one thing that needs to unfold, like a solar array that you can see here, or maybe a communications antenna that you can see here. James Webb has over 1,700 different deployments that it needs to do, 1,700 different things that need to go right in order for this telescope to work in space. You can watch the series of things that are unfolding here. Right now, the cover for the sun shield is opening up, and the sun shield is going to deploy fully in space. This thing is the size of a tennis court. It's huge. And all of this is happening thousands of miles away from Earth, out in space, automatically. And you can see the sun shield is opening up. There's 5 layers to it, and it's all tensioned and stretched out. And now the secondary mirror is deploying. That's what's going to capture the light and focus it into the instrument panel that's on the back there. And now finally, the 2 sides of the primary mirror that had to be folded up are now opened and complete. And James Webb is complete out in space. So we are so excited for this all to happen next year. The telescope is launching in October of 2021. And just like Hubble, it is going to bring us incredible discoveries from the cosmos. We can't wait, and we hope you're there with us watching the launch and waiting for the exciting science that that is going to do. Thank you.